I'm here today to talk about buildings and sustainability. But before I jump into all the numbers and bore you with a lot of stats and things like this, I want to ask you a very simple question to understand if we are actually talking about something that is worth to talk about. How many of you have lived or worked in a building? Okay, that's the answer I wanted. And so it is something that we should talk about. And the reason why I'm saying this is because today the building and construction industry is responsible for 40% of the CO2 emissions worldwide every year. To put things in perspective, transportation, flights, cars, trains, all of this is 25%. So it is something to talk about. And maybe the first thing that popped in your head was, okay, we just have to turn off the heating, we should reduce the electricity consumption, and so on. Yes, we should all do this, don't get me wrong, but this is not going to help. I'm here to disappoint you. And the reason why it's not going to help is because we have to think about the problem in time. Whenever we build a building, maybe we are not aware, but we are already producing a lot of CO2 emissions. This is what happens when you actually create a structure. You lock in a lot of CO2 emissions. When you start using the structure, then you start doing all these emissions related to heating, cooling, and electricity. We can reduce the operational part, but we cannot do anything about the embodied part. If we do a mistake today, that is going to be locked in there forever. And on top of that, our problem is not in 100 years. We have to find a solution in the next 20, 25 years. And so most of it is going to be because of the building, not because of the use of the building. On top of that, to make things even worse, just because I like to give bad news, is that this is not the only problem. This is just the tip of the iceberg. We conveniently talk always about CO2 emissions, but there are other problems, and the construction industry is largely responsible for this. We are taking a lot of materials from the planet, and we are not using it very well because we build buildings that are not very well done, and they don't last long enough, so we have to demolish them and build them again. And this is not going to get any better, more bad news. Because we are going to grow 2.1 billion people, and this will require 90 billion of square meters of new construction. This doesn't make much sense to you, I hope, but this will. We will have to build one New York City every month for the next 35 years. Everything that you see in this picture and more, every month for the next 35 years. So it's clear to me, and I hope now it's clear also to you, that we cannot do what we are doing now. We need to change the way in which we design and build structures, buildings. This is a solution. I see the despair in your faces, but I put it here not because I want to scare you, but actually because I want to motivate you. Because this is actually a very simple equation. What this equation is telling us is that the global warming potential, so how bad our buildings are, it's only a function of three things. How much material we're using, how good or bad this material is, and very importantly, time. If we build good structures that last longer, we produce less harm. This is a nicer version of that equation. What is telling us, this equation, is that we have to reduce, we have to improve the materials, we have to prolong the lifetime of our buildings, make them modular so that we can reuse them, reuse parts of them in time, and then make them easy to recycle. All those principles were actually there thousands of years ago, hundreds of years ago. They were at the base of structures like this one. Most of these structures were actually made from parts of other buildings that were taken from the surroundings. These structures are undoubtedly beautiful, but also are very, very efficient. Proportionally, one of those shells is as thin as an eggshell. Crazy, huh? These guys, they didn't have computers, they didn't have fancy mathematical models, and yet they could do things like this. Now we have computers, now we have fancy mathematical models, so we can do even better. If we apply these principles to modern construction, we can already save 2/3 of the materials that are surrounding us in our buildings. 2/3. But now, which materials should we use? And now it's the second poll of the day. How many of you believe that this is true? Wow, this is a very educated. Okay, 50-50. Also because this is actually 50% true and 50% wrong. Because concrete is actually very polluting today. It's responsible for about 10% of CO2 emissions today, cement production. But the problem is not concrete itself. Concrete is a very sustainable material per se, as a material, has one of the lowest embodied emission and embodied energy coefficient of all construction materials. The problem with concrete is not the material, it's the use that we do it. It's the second most used substance in the world, after water. And the reason why is that is because it's actually very versatile, it's very useful, it can be used everywhere. But we've grown to use it everywhere, even where it's not needed. Today, we can do better. We can make the production of cement better. We can reduce the emissions related to the production, but we also reduce how much cement we put in our structures. And again, we can save 2/3 of the emissions that we are producing today. So when you combine these two things that I described before, when you combine the good geometry with the good material, then you can, allow me the approximation, have a fraction of the global warming potential of a structure. However, these were drawings. We have to actually solve the problem today in a large scale. So we need to understand if we can apply these things in these buildings. So if we take an X-ray of one of these buildings, it will look like something like this. 75% of the entire mass in a building is in the structure. We are only 5%. We build buildings that sustain themselves right now. And most of this mass, most of this material is in the slabs, is in what we use to walk, to put things on. 40 to 60% even. So if we want to make a change, probably we should start from there. And the reason why they're so polluting, they're so massive, is because we build them like this. We put a lot of material, we mix materials together. This thing that you see, it's impossible to reuse and very, very, very hard to recycle. But so we learned something today. We learned that we can save mass, we can use better materials. If we do a leap of faith that this works also in 3 dimensions, we have something that is a little bit more complex, but at the end of the day, it's the same principle. It's the same thing that was behind the Gothic cathedral. And this is what we call a funicular floor. We test this thing extensively over 10 years of research in TEDxStuttgart. We put our life at risk. This is 1 ton of nerds happily demonstrating that this thing works. And then we finally build a real building. It's a bit crazy building, but it's a real building. It's a real office. In this building, we put 2 of these floors, about 20 square meters each. And these are the floors. And these floors, they show us that we can do with good structural geometry, we can do something that is beautiful, it's elegant, but it's also very efficient. 50% less concrete, 80% less steel, 70% less emissions. Of course, the geometry, of course, the vault, but I want to catch your attention on one thing, that little dot that is there. That little thing is the only reinforcement bar in one of these concrete floors. And so you see the difference between what we can do and what we are doing right now. And we can do even better, because we removed all this steel from inside of these structures, so we can start cutting them off and produce them in factories where everything is more efficient. We can deliver them on site, put them together very easily, because again, there is nothing to connect. Everything is in compression. Put the keystone, the Schlussstein, the only German word that I know, and then you have something that is stable and safe and ready to take any load for which was designed for. This was the first of 180 of similar floors that we will build for this tower next year. These buildings, they show us that it's possible already today to have better solutions, to apply them at large scale, when there is a combination of researchers that bring new ideas, practitioners, engineers that embrace them, and clients that they want to change the status quo. What I hope I showed you today is that with the right geometry, with the right material, learning from the past, we can turn the most polluting material in the world into a beautiful and sustainable structure. Thank you.